Jason, Corinne Anderson, Logan Helstor, Tyler Hopkins, Matt Davis, Corey Rucker, Nick Fabiano, and Dylan Hisbitch. And so, a big summary for the project is to develop either a modified recorder or an adapter for Naya so that she can play the recorder alongside other students in her music class without needing special instructions or private lessons. So, a little bit about Naya. She is a 8-year-old girl from Indian Island with a disability that she calls her wiggle. And this has unfortunately made her unable to play the recorder fully because she needs to be able to cover the notes, and because she's learning the Baroque style. She's learning the non-traditional way with her right hand on top so that she can follow along with her students. And so we needed to come up with a device or modify the recorder so that she can use her wiggle to play along with the rest of the class for the other habits. So the design approach, we had numerous ideas, and as a team we were brainstorming a lot of ideas that focused on being the safest and most ergonomically correct for Naya. And after moving ahead with the best choice, we created a prototype, trying to flesh out what we needed and what was also best for Naya. We were able to actually do this pretty quickly because we have MakerBot 3D printers on campus, and so that melts filament into the shape, so we can actually get like these out pretty quickly. Like I think this took 4 hours to make. So if we needed to change something, we could be able to see right away what we needed to change the design, and print it up. And so after finally finding the right design, we met with Naya to receive her input as well as her music teacher, Melissa Martin. And so just to show a couple of pictures of the design progress, we started out very simply with this. It's kind of hard to see, especially if you're in the back. It was a really simple key design that you would push down and a magnet would hold it in place, but it was a bit hard. It didn't seem very good for Naya. And so then we slowly moved to this, which you see now in our final design. And that seemed a lot easier for Naya. The keys are a lot bigger, so it's easier for her to hit. And she can also hit this top part, which has her name engraved, so she can play combo notes if need be. And I will pass it off to Corinne.
I'm Corinne. I'm going to talk about the final design. This was what we had come up with. We had neoprene rubbers that sealed the keyholes underneath each of the paddles, and we had put in grooves so that the clamp wouldn't slip or rotate around the recorder. And we suggested a bunch of key designs for Naya, and she picked her favorite one and added adjustments that she liked, like the soft rubber on top, so she could hit it without getting hurt. And it's an ergonomically correct paddle design, so she doesn't have to reach around or potentially hit other pads. And then we put a plate and a thumb screw to attach it to a microphone stand so she could take it on and off easily and use it easily. These are the notes with our design that she can play. They're the same, so she can follow right along with her classmates, so it's easy to learn. We aren't able to play half notes, but we hope to be able to do that soon. And then we also would like to thank our sponsors and supporters, especially AJ for teaching us all about the 3D printing and giving us the software to be able to do that. And David Dvorak, one of the professors here, he was a PE sponsor for us. And then there was a few others. Jess Gleason, she talked about ergonomics and safety. Jerome Busher, he was at D&G Machine Products. Dean Dahlham was another PE reference, and Gary Walker was a metal specialist that we spoke to. Are there any questions?
Sorry, I rushed through that very quickly. Any questions? Awesome.
And we're going to tell you a little bit about our design process and our project and how we came up with design. So I'm being tasked with coming up with a design and manufacturing something that would allow Naya to play the recorder. We met as a group and had a lot of design meetings the amount of time and money we had left, and with limited access to NIA, we wouldn't be able to make this design in the budget that we had, in the time that we had, and without, having her meet with a professional, so she didn't teach her how to use my electric sensors.
So my name is Taylor Jacobs, and I'll be telling you a bit about what we had going through our mind when we decided to change. So our revised design is based off of Enabling the Future's Cyborg Beast model hand. We have taken their design for this hand and we've adapted it into what we want to use it. We've taken flex sensors, as you can see right there, that when she puts pressure onto the sensor, it'll send an electrical signal to the motor and it'll play what we need it to play. Now, these are all going to be hooked up to an Arduino Uno R3 board. That's going to be the brain of the computer, brain of the entire ordeal. Now, these sensors that we have in to prevent any cutting, scratching that may be on them, we've infused them into the silicone mold you see here. Now, why did we change the design? The aluminum to polymer change, we decided to change because the amount of time it would have taken to manufacture each of the parts for the aluminum design was just way too fast. We would have had to send it out to a machining company, spend numerous amounts of dollars to get everything made on specialty machines due to angles that you would have had to fulfill. The weight of it was also going to be very heavy, with all the worm gears integrated, with all the motors integrated into the fingers. It was going to be very hard for her to keep the hand in a plank position. Not to mention, our design had not been proven. The Cyborg Beast has been proven. People have made it, they use it, it works perfect. Now, the pros of each design, as you can see, the aluminum design didn't really have too many pros. Mainly, it had a good lifespan. Aluminum is very resistant, susceptible to scratching, but it holds its integrity. Now, with the polymer design, 3D printing parts is easy. You can do it very quickly, very cost effective, and the polymer design, again, has been proven. Cons of each, aluminum is very heavy in comparison to polymer. It's very costly. If anything breaks, it's going to be very expensive to send it out and get a brand new piece mailed to you. It is not an effective way to do it. Now, with the polymer, it's plastic. It breaks. And when you're printing, it can leave things a little uneven, a little rough, and it just looks a little unsightly.
Alright, so I'm going to talk a little bit about some of the technical specifications and why we chose the different components that we did. Like Taylor mentioned, the board that we chose to control the whole operation was the Arduino Uno. And the reason we chose Arduino is because it's very user-friendly, it's designed for beginners, and it's an open source project, so their website's great. They have a lot of support material on there, they have a lot of forums that you can read. So you can teach yourself enough about programming to do what you need to do. So that worked out pretty well. The input from the sensors, we used variable resistance little force sensors, and as you saw, they were pretty slim, really small, flexible, and so they were perfect for our application. They're embedded right in the silicone, and the harder you push changes the resistance, and with that changes the voltage, and so the board reads varying voltage and uses that as its input to output signal to the servos. The servos that we used are really small, lightweight, little middle gear micro servos, so just about as small as you can get. We wanted to keep everything as sleek and slim as possible for obvious reasons. And but for what they are, they actually put out a decent amount of torque. They put out 25 ounce-inches, I think is what they're rated at, and which is more than sufficient to cover the holes in the recorder. And so those are the motors that actually the pendants move fingers. This is just pictures, something different. Like the one on the right is our original design that was going to use linkages and boarding gears and everything, and then the one on the left is the enabling features 3D printing that we actually use for the project. Here's a couple more pictures just so you can see. That's the final product there on the right. You can see the tendons that the servo motors pull. And servo housing we also 3D printed, which was great because producing something like that would have been pretty challenging without the 3D printing. I want to make sure we thank all the people that helped us out along the way. Definitely got a lot of help from the Hanger Clinic. Those guys were very helpful. The guys in the prosthetics department over at EMMC were also a big help. Even in the future. Also want to thank a couple guys that are up there on the board. Sean Erie, he's the guy that works at the Composite Center. He was our advisor for this. And also, probably along with every other group, AJ helped us out along the way a lot. So I want to make sure we thank him. I guess that's about it. Unless you guys have any questions.
We're team one, the NAT Capstone. This was our inspiration. We toyed around with a bunch of mechanical designs, as you've seen. Ironically, we had all the same designs. If you look after we had come together and nothing was proprietary anymore, everyone kind of had the same idea, at least at one point in the design time frame. So this is what we started with, and we kind of curtailed it into something that Naya could use. We had a short clip of this.
Unless the video picture was on a machine, right? Does it not play?
No, it doesn't have to. It worked on my computer.
Is that a link?
Yeah. I guess you don't have to watch it. I can explain it though. What it is a gentleman over in Japan had created a recorder using a fan, and it had a solenoid valve to, I guess, tongue the note. So that would be when you're changing notes. And then he ran it through an Arduino, and the Arduino would control all of the notes, and he had programmed the song into the Arduino so that the solenoids would finger the notes on the bottom half of the recorder. So we kind of took that design and ran with it. So the wiring, initially, we spoke with Joseph Haggerty of Southern Maine Communications, who told us that we would need diodes to prevent backfeed of voltage. And that's so that we could use a few switches and multiple solenoids. And then we created a simple wiring diagram, and we were putting diodes in place where they were needed. And those were a few people that helped us a lot with the wiring. It was a long 5 hours getting the wiring to actually work. This is our initial wiring diagram that we hammered out in about 5 hours, and our initial mock-up. And that proved our concept and design. Every button dropped the solenoid that they needed. With the help of AJ Rutherford, he soldered up a breadboard for us, so it's nice and compact. And that's what it looks like inside that cover. Nicely shrinked tubes. And these are our playable notes. These are the 9 required notes, and those are 8 more notes that the solenoid design is able to play. And with that, I'll hand it off to Sean, and he'll talk about the solenoid housing.
Hi, I'm Sean Steele, and I'll tell you about the physical aspect of our design that supported the electrical part. So this was our first solenoid housing, as you can see. Basically all we did was make square boxes to push the solenoids in. It's but the clamp towards her right hand was too close for comfort to play easily. And all the solenoids are on the same level here, as you can see. So the recorder doesn't have a flat contour on the top. So the stroke length of the solenoid had to be adjusted according to where they're positioned to make them meet the recorder. Also, the shafts of the solenoids are able to rotate, so our hole sealing design wouldn't seal the holes if the shafts rotated. So we had to fix that. Also, the solenoids were loud, which they're still louder than we would like, and we have some work we could do on that, unfortunately. But we cut the sound level down by half from what it was, so it's a lot better with that. So our second solenoid housing incorporated using buttons to actuate the solenoids the way they needed to be to play the notes. So we just extended the box up to the right, also extended it up to the top to completely enclose the solenoids. But we're still using the same tabs, so we had the same problem there. And the wires were loose. They weren't contained like they needed to be. Solenoids were still loud, and they're still on the same level. So we had to modify this to make it more compact, and hopefully look better, and be more functional. Which is how we got to our third and final design, which is basically this, with this housing built around it. So the solenoids still pushed into here, except they didn't have these walls in there, so you could adjust them linearly to be able to position them over the holes as you needed. So they pushed into here, and then there's a rib inside there for the top of the solenoid shaft. There's a slot in the top of the solenoid shaft that lines up on that rib, so it'll keep it from rotating, so we can seal the holes in it. Also, the buttons were located so that the stem on the button would go between the shaft of the solenoid to make it as compact as possible. And also on the back side here, we made room to put the breadboard. So all the wires come through the back, wire into the back, and there's a door that clips on there. They can't come off very easily. So it's as compact as we could make it, and it looks better than being boxy, and this would have been bigger and boxy. So at this point is where form finally met functionality, and that's where we ended up with that. So at that point, I'll pass it off to Ryan to let him explain how we support the device, so she doesn't have to hold it with one hand.
So I'm Ryan, and like Sean said, I'm going to talk about our support system, kind of our design process, quick design process, and why we chose what we did. We went through a few different
me and my design team from the get-go wanted to create a product that incorporated these springs and attachments in a simple and subtle design that Naya could use not only to incorporate her pinky, but also her wiggle key.
So in case you guys didn't notice, we're Team 4. And from the left here, we have Dylan Johnson, Travis Sherman, Corey Dennis, myself, Justin Dokovich, Brian Kearns, Aaron Koss, and Gentry Birch. And a little bit about the team. First off, we have Brian. Brian was acting as the project manager, and he was pretty much responsible for everything in regards to organizing the team. So that comes to team meetings, objectives, and then also fulfilling logbook requirements every month. Then we have Aaron. Aaron was the lead design engineer, and he was pretty much responsible for the design that we have today. And that goes from everything from the conceptual design phase to the mock-ups, to the revisions, and the final product. Then we have Corey. Corey was a sound specialist. He was responsible for the spectrum analysis testing, along with the pad selection tests, and also many other tests performed around the group. Travis, he was a safety expert. He was responsible for figuring out the sanitization testing procedure, as well as the cleaning procedure, which we wanted that to be as quick and easy as possible for us to do. Then we have Gentry. He was the assistant project manager. He did a lot creating the Gantt charts, which helped out our group immensely, creating long-term goals and objectives that we needed to accomplish. He also was the requisitions person. If we needed anything, we went to Gentry, and he had it. He had the money, whatever we needed. Now I'll talk a little bit about myself. I was the webmaster, and I was also another sound specialist. I helped conduct the spectrum analysis test and the final decisions on the pad materials and pad tests. Then finally, we have Dylan Johnson. He was an ergonomics designer. He helped out a lot with very good ideas in regards to the pinky keys, which helped out with curving and playing. He also helped out with the case design, which, as you can see, I don't know if you've noticed, it looks beautiful. And on this slide, despite going through all the design factors that we were given, I'm just going to talk about what our group wanted out of this project, what we wanted to show, what would make our product stand out. And one thing we had in mind was that we wanted Naya to be, to learn this as quickly as possible. Another thing was that we wanted to make sure it was a little bit discreet, so that in the classroom it wasn't standing out. Another thing was we wanted to make it cost effective. Cost, as you know, with 3D prints can get pretty pricey, somewhere up to $200. And we also wanted to make it similar to existing instruments that we have today, like clarinets and flutes. But despite all those things that we wanted, we also had design constraints, such as a budget. Initially, we only had $500 in the budget. So we designed for $500, and we eventually got 1,000, which helped out a lot. And we were able to do a couple extra flashy things to help improve the aesthetics. We also had to consider Naya's wiggle sensitivity to temperature. So that meant no metal touching her wiggle, which was key in the paddle keys, if you notice on the bottom of our report. We also wanted to ensure that Naya's cleaning process, as I stated before, was as quick, clean, and efficient as possible. Also, safety was another huge concern for our group. Thanks, Justin.
So now you guys have an idea of where our design goals wanted to go and the direction that we wanted to take this project in. I want to start with our initial concept, which Aaron Koss thought up on October 23rd, 2014. I remember the class time he actually thought of it. He was actually an engineer in economics in this very classroom. It was based off a 180-degree twist for the lower two notes, and we initially made the mock-up out of a plastic quarter and flute keys that were jerry-rigged on this thing from Bangor Brass and Woodwind. So by November 19th, we got our first working CAD model, and that's what you're seeing in front of you. One of the big problems that we found, though, is that the post actually broke after using it, and that's because it was too thin. The fillet in the middle wasn't strong enough, so that was one of the edits that we made later on, which I'll to take this time to thank L&K Manufacturing, who actually printed our first CAD model at no charge to us. So after we had our first prototype, we ran into some problems. And that's going to happen with any kind of project because you design, you prototype, you make, and you analyze. Some of the questions we faced were, how are we going to sanitize this? How are we going to make it stronger? We have to worry about the pinky key and how the ergonomics are going to work for her. And also, which kind of pads are going to seal the best. So after this, we really started hammering down. Our team leader, Brian Kearns, stepped up in a huge way and got us all moving. The first edit we made was actually a suggestion from professional engineer Herbert Crosby, and that was the addition of support in the posts, which you can see in the left picture. And we also decided to make the pinky keys metal so that they would be stiffer. This provided for better sealing and in turn made our product better and easier to use and play. The second thing we worried about was cleaning, which this is the key stage that I've focused on. Thanks to Kirsty Moriarty, we were able to do a bioculture on 2 discs, one soaked in a Stericyl germicide dilution, then a second disc that was soaked in a bleach dilution. After a 48-hour incubation period, we found that the bleach dilution cleaned over 30% more effective than the Stericyl germicide dilution, which that's one of the reasons that's mentioned in our cleaning procedure as using bleach. One of the notes we have though is that you cannot submerge our lower recorder into bleach or else the pads will get ruined. So this is all specified in the cleaning procedure. So here's a little diagram about how Naya is actually going to play this recorder. And it starts with her right hand providing force down and her left wiggle providing force up. Her mouth is going to be used as a pivot point. And the way this works is it pretty much acts as a fulcrum where she can seal all the notes and the 2 contradicting forces counteract each other. Another thing that helps is that this recorder weighs 51 grams on average more than an average Angel Halo recorder. And this adds more force in the downward directions for when she tries to seal the wiggle keys. So the final product, after 655 hours, a lot of teamwork, and over 6 months, we have a custom case, a logo on the front, Velcro straps, so it's easy for Naya to open. And we also have a fully functioning flute recorder, which Naya can use. It's a subtle design. It uses traditional springs and keys, which is what we initially wanted to do. And it also has a pinky key attachment. What we were thinking about was if Naya wanted to continue playing after this, as far as whether she wanted to play a flute recorder, a regular flute, or a clarinet. If she wants to do this, she's going to have to get used to using her pinky in a not-so-normal fashion. So our design really emphasizes this because of the pinky keys and also because of the wiggle keys. These are our donations and sponsors. I want to give a special shout out to L&K Manufacturing for donating an over $250 part for us for free. This was one of the main contributors for our low cost. It took us $76.73 to make the recorder that you saw in the previous slide. I also want to thank Kirsty Moriarty for her help, Karen Signs, Bangor Brass and Woodwind, Herbert Crosby, and Kenneth Sanders. We were a little skeptical at first when we started this project, but when we pitched the idea to people, they really took it with full force, and I was amazed at how much help people would give for no cost at all. Thanks for listening.
Now let's get right into it and give an overview of the design progression of our project. From the start, we quickly found out that instrument making is definitely a specialized field in that the design process for it can be very iterative. And we found ourselves perfecting the design throughout the entire project. As with any project, we would have liked to achieve a perfect design right from the start, but as we all know, that's not always realistic. And so, from the beginning, we identified that with our recorder design that we needed a series of valves to actuate the different hole combinations to achieve the required musical notes. And with our first design on the left there, we came came up with a device that directly attached to a Yamaha brand recorder by slipping right over the end of it. This device featured 4 spring-loaded valves that naturally sealed the bottom 4 holes. And we designed those valves so that they would be mechanically connected to achieve all the different note combinations. And with our second design on the right, we kept a lot of the same functionality, but we greatly improved on the ergonomics and ease of use. And we did this by combining the valves with the body of the recorder to make an integrated piece instead of an attachment to the recorder. And we also identified that by incorporating the use of Naya's right pinky and reversing the valves to be held naturally open, that we could reduce the number of valves to 3 instead of 4, and also remove the need for any mechanical linkage to achieve the different notes. And this approach really simplified our design for obvious reasons by reducing the number of parts and also reducing the overall size of the recorder. And so now I'll hand it over to Emily to talk about some of the design criteria that we focused on.
So, folks, I'm Emily Shannon, and I'm going to talk about how our design met the design criteria. So one of the most important factors is making sure the design is safe. Our design has no sharp edges, no pinching hazards. Pretty much there's no small pieces that can fall over, fall off. But it is also really inconspicuous. It looks exactly like the normal body of a halo recorder that we were given. It also follows the standard road fingering that is being taught in Naya's class, so the teacher will not have to dedicate any extra time, and Naya will be able to learn right along with her classmates. There is no metal used. Well, there actually is a rod that connects all the pieces, but it is not in contact with Naya at all. We also met with Naya 3 different times. As Cole said with our first design, it didn't really work for Naya. It wasn't comfortable for her. So our second design, we made sure to meet with her twice, adjust the angle of the valves. That way she'd be able to play comfortably. As you saw with the case race, our case is just a simple zipper. You pull the recorder out and it's ready to go. It's very easy setup time. It's not detract from the class at all. Lastly, our design, since it's just like a normal recorder, it'll grow with Naya. She has to play for the next 2 years, so she can use the same recorder and doesn't have to change anything with our design. So I'm going to pass it on.
Hello, I'm Ethan Eisenhower, and I'm going to talk to you about the design issues and solutions that we came up with. As Cole stated, they're naturally closed, had some issues with that. We had to have some linkage to connect them to get the F sharp. When we moved to our second, it was naturally open, and also using the pinky, it negated any of the issues with F sharp. You can get it easy now. Another issue that we had was the angle of the valves with our second design. Originally we had them on the side of the recorder. When we went and met with her, she found that when she was trying to play it, she was pushing on the valves and it kept rotating. Second time we went and met her, we rotated them a little bit, try to get them more to the underneath. And then again, when we met with her again, we moved them once more to get more underneath so their forces are going along with each other. The sealing was a big issue we had with our first design. We were trying to use a universal idea so you could put on any Yamaha recorder. That was one of our points for our first design. We found the sealing with the radius on the recorder was quite hard to get it perfectly right. With the maker bot that we had, the tolerances on that weren't exactly working with us on that. The second design, we flattened them, and as you can see in this picture up here, the holes have a raised ring around them. And if you look at any kind of clarinet or anything like that, they have those rings around them to lessen the surface area that has to seal, so it's easier to seal. Another issue that we were trying to figure out in the beginning was what kind of springs to use. We contemplated different kinds of compression springs, torsion springs. The first one actually used you might have seen them all the time in battery slots, the little battery terminals. We used a T-slot in our first design, and they slid right in. They were press fit, so it negated a choking hazard or anything like that. But we found that using using that as with the naturally closed, it didn't really work with us. And then when we went to the second idea, this one, the spring concept was a little too high, too much force to close it. The idea we came up with is having small helical compression springs in there. We played around with different spring constants. We ordered a couple different springs in and pretty much tested which one we thought would be the easiest for Naya to operate and wouldn't put a lot of strain on it. The final design, as you see up there, we have naturally open, as I said. It can play all the notes. They're easy for her to get to. Another thing I did fail to mention before is we moved the pinky finger. Originally on a normal recorder, it's pretty in line with the rest of the holes. We moved it to rotate to the right to fit her finger more. We didn't move it all the way over to where it is completely comfortable now because we were looking for it for the 2 years where she's going to be playing and we'll be able to grow into it. As stated before, the Naya's right hand will play the top 4 notes and the wiggle will press on the 3 keys, alternating into which note she needs. But also, I would like to thank our sponsors and some people that have helped us. Sean Erie is our PE that we talked to a bunch about this. Glenn Sargent, a professional in woodwind instruments here at UMaine. Also, Joe Shaw at Bangor Brass and Woodwinds donated some things to us. Any questions? Thank you very much.
They started off sort of in the beginning with the design and ran with it until the end. That was not the case for us. This is sort of a look at our earlier concepts when we were brainstorming. Our first real design that we tried out was this one up here where we would have some steel bars that you would push down at certain locations to try to play the different notes. But as we quickly figured out when we just tried some steel bars is that it's too compact of an area and we couldn't really get it to work the way we wanted to. So then our first design that we tested and worked on for most of the year was the manifold. The concept behind the manifold is that you would move the bottom 3 holes of the recorder all into one triangle so it would be convenient for her to just play it and play the notes with her wiggle. But we ran into many issues with trying to reduce the squeaking from just from adding all of this extra material, moving the hole and putting it there. We tried all sorts of things like increasing the diameter, decreasing the path it would have to take, making as short a path as possible, and we just couldn't get rid of the squeaking. This is one of our final designs we had here where we were going to put this sort of triangle attachment over it that she could sort of rock back and forth, and it would have a spring that would attach there, and it would have some seals on it so it could close those 2 notes directly, and only this note would be moved so that you would still keep the triangle shape. We still had some squeaking playing the notes like C and D that required 2 or 3 of these to be closed. And then finally, the reason that we finally abandoned it was when we showed it to Naya, we sort of realized it would be more difficult than we anticipated for her to sort of play some of the notes with the triangle. She'd sort of have to reach in odd directions to play some of the notes. And then we looked at a German fingering recorder because they're made to be more simple for school use for beginning to learn it. The only difference in a German recorder is that the F key is played with these top notes. Actually, these top notes you don't have like in the Baroque. You have this one open and the rest closed, so that way we could make this lever design where if you close this bottom lever, all of them close, or if you close this one, all the ones above it close, and we could just play the notes in sequence. We also showed this design to her, and she seemed to, it was really easy for her to use, and we decided to sort of go with that. We still wanted it to work with Baroque though, so we tried adapting it for Baroque. What we did is we took this third hole from the bottom could play the F key by pushing up this lever, closing all of these, and then she could open the note that would needed to be open on the F. Unfortunately, we were trying to make this design work through this weekend, but we just couldn't get this to seal correctly. So we moved on to our final design using a German recorder, and Rob is going to talk to you now about that.
My name is Rob Barkley, and this is our final design. It's a 3D on a German recorder, so she learned to play the recorder this past year with her right hand on the top, so she covers up the top 4 holes with her right hand. So the bottom 3 are used for keys, and when you push down the top key, there are these like levers that go underneath each of them. So when you push down the bottom key, it lifts up all the others as well, closes up the holes. And because of the German, to play the notes in sequence, you just cover up each sequential hole, and so to go all the way down, you just lift up the levers. And we went with this because it was the simplest design and it was the easiest to work. And the ceiling we got to work really well, and actually we got it to work like 2 days ago. And so we were pretty happy about that. So when we first came up with ideas, everything needed a support because that would be the easiest way to hold the recorder. And so our original design, we did a little bit of patent search for clarinet holders and things. And so our original design was this one, which ended up being rather dangerous because if she fell forward, it would like spear her. And so we came around with a couple of different ideas. And well, like other groups, we came up with a harmonica recorder or harmonica holder, which when we went and visited her, we talked to her about different supports, and she actually liked the best when it was attached to the ground, like on a mic stand or something. So we ended up going with a mic stand holder. So you just use the clip and it holds on the bottom of it, and all you have to do is like you can adjust it for if you're sitting or if you're standing, and you just start playing. And I'm going to hand it off to Drew.
Hi there, my name is Drew, and when we first started this competition, we had some budget guidelines that the class came up with, as well as Melissa that she wanted to meet. So one of the criteria was that it had to be safe, which ours is. And one thing that we kind of take pride in ours is that it's so simple and compact. And the reason for that is because we chose to go with the German design. So there's not a lot of things that can go wrong with ours because there's not that many moving parts and everything's so simple. It does play all the required notes. It has its own case, which is also very compact, and there are no metal parts that Naya has to hold on to. It can be easily disinfected, and it doesn't need to be changed as Naya grows. And it also can be played sitting or standing, just by adjusting the microphone stand that we got. We'd like to thank Connor for his 3D printing. Ben Light, he is no longer with us in the second semester. John Belding, he gave us some advice for in the first stages of the recorder, and kind of helped us out. He's the one that told us not want to abandon the support design, and the AMC for allowing us to use their conference room. Is there any questions?
I'm Ryan Ross, AJ Rutherford. We're noteworthy engineering. Alright, so our design challenge, as you know, is to design a recorder that would be able to be played by a one-handed student. Part of the design challenge was to not use any metal contact surfaces, and so what we tried to do in our solution is print with ABS plastic. AJ is our 3D printing guru for this whole Capstone project, as most of you know. So we decided to use ABS plastic because it is lightweight, strong, durable, and it is temperature resistant, so you can put it through a washer to sanitize. It won't break down up to 100 degrees Celsius. Our solution, we went through quite a few concepts, starting with our initial design, which was just a PVC sleeve, and we continued on, and we used Ninja Flex with an ABS shell. And part of the issue that we had going into it was getting the notes to seal properly. We really wanted to keep our design in-house and be able to manufacture it ourselves. That was a huge part of our project. We wanted to keep the costs down, and using a 3D printer that we have with a cheap material like ABS made that very possible, and we were able to rapidly prototype and produce different solutions. So we moved on to different barrel solutions to try and get the certain notes to play as you rotate. And as we moved to our final design, we changed to a 5-barrel solution, and we had a lot of variations in that. So essentially, what we ended up doing is assigning a different barrel, which you can see there. Each one of those plays a different note as you rotate the recorder barrel. And so yeah, so that's what we ended up doing. And to help balance it out, we added a lock line brace so that when she's not playing, she can have her hands off it and doesn't have to worry about it going anywhere. Our setup and cleaning, pretty easy. It comes in the case as is, so you just take it out. She can put on the sleeve, and she's ready to play. As I said, it's machine washable, and we have supplied the Mighty Mist, which is 70% propanol, water, a little coloring, and yeah, that's how it is. So some of the challenges we faced were obviously with our 3D printers. Sometimes they malfunction and break. Thankfully, we had AJ around to fix it up and program it when needed. Sometimes our ABS would curl on the build plate, which throws off the entire build. As many of you know, that's a time-consuming process, so when you have to start over again, it can be kind of a pain. We also wanted our barrels to seal well. That was an issue we had. Trying to get the barrels to line with the base of the recorder to make a nice tight seal, so we get a nice clear note playing through it. And we wish we had had more time to contact Nia and work hands-on with her, but sometimes that's just how it goes. Aesthetics. We think our solution looks pretty cool. It's also fairly well balanced with the whole lock line, so it's easy to use and pretty simple, you know. Each note has its own associated barrel, and yeah, I'm going to pass it on to AJ.
Good afternoon. Durability was a big factor in this, being able to print in-house. One good thing about ABS is it's one of the stronger plastics that's commonly available. It's also very inexpensive, 30 bucks a kilogram, so about $13, $14 a pound. You can get as low as $10 a pound if you're clever or lucky. It's also very temperature resistant. I've actually thrown Legos into the washing machine or the dishwasher, and they've come out perfectly fine after my kid gets sick on them. So there's a big history behind that. The most common ABS that everyone knows is in fact Legos, which are precision formed in $500,000 molds, but it's a little relevant. Ease of use, ergonomics. This was a big problem. Our early designs had a very tiny radius, not much larger than the recorder itself, which means it required a lot of force to turn them. We decided to go larger because a larger radius means an easier moment to turn. to gain the same amount of force. As Ryan mentioned, we added the brace and the lock line with the Polyflex 3D printed components in between to hold everything together, keeping as much of this in-house as possible and balancing the whole thing. One side feature of this particular design is the ergonomics for an instructor. One of the barrels is set to open, and you can actually play the modified recorder as a standard recorder in an instructional setting, which we thought would be a big help going forward for any teacher who's trying to teach a student to use it. We center the weight. That reduces continued fatigue. You don't want your arm bending around all the time if you don't have to. And we made sure, and we purchased high precision bearings to ease the spinning process. Carrying case was homemade. Again, we're keeping everything in-house, made by Leroy. We wanted something that would, stand out, in its own fashion without being too obvious, and to keep the costs down for everything. Dynamics. This was specifically designed to mimic an actual recorder as much as possible. We took a hybrid approach and went with recorder / pan flute, where we have essentially the 5 pipes that mimic the 5 notes. In this case, instead of having a straight line, we have a rotary fashion, which means you can go right from the highest note back to the lowest note and hit everything in between. Pat, one of our teammates, put some serious time in the machine tool lab, getting precision cuts of a bass recorder to fit the modification, and the design as is made for a very limited change in note tone. Cost was very low for us. You can see by the numbers here. The average modification was about 150, somewhere upwards of 200 grams. This was due not in small part to the 3D printing process, where we could use a low shell count, the outer layer, and a light infill, the inner layers, creating a very light object. We had 150, 200 grams, bit of wear and tear on the machine. Electricity for the 3D printer only cost about 8.5 cents an hour, so it's not terribly expensive. And we had some outstanding hardware that we couldn't just manufacture. That was about $10. So our modification cost about $15. The brace itself cost about another $10. So just the recorder is $15. The whole enchilada was about $25. We would like to take acknowledgement. We'd like to make acknowledgments to the MIT faculty who've helped us throughout the year. Naya herself, sorry about the misspelling, it was my fault. And Beth Johnson, an occupational therapist, who helped us get the ergonomic issues really locked down. Are there any questions?